Hi everyone. In lab 7, we are going to use the strain gauge to measure strain in a cantilever beam. Strain gauge is a special resistor, so we would like to measure the strain, which is the ratio of change of length over the original length. And unfortunately, this delta L is tiny, so people came up with an idea to measure the strain by measuring the resistance. So it's a wire that is meandered like this, and it's basically measuring the strain in this direction. So the strain gauge uses delta R to measure delta L, but the problem is this change of the resistance is very small. So they came up with an idea to add this something called a Wheatstone bridge, and they are measuring the change of voltage instead of the change of resistance. And the equation follows in this way, but the problem here is this voltage change is still so small. So what we're doing here is we are adding additional amplifier so that we can amplify this voltage that is very small by some ratio, and by measuring this we will be able to find the strain value finally. So you are measuring this voltage, and then that is the value that is magnified. So this voltage is being used into this equation, and we are finally finding the strain. By the way, all these values should be the same value because we are basically measuring the strain. This one, the strain, the change of L, they should be all the same thing. So in the lab, what we're going to do is we are going to form a circuit like this here. This is the Wheatstone bridge, this diamond shape. By the way, one node should be connected to the strain gauge directly, because strain gauge is nothing but a special resistor, right? And you are going to use, in case you have a strain gauge that is 120 ohm, in order to balance that, you are going to use all the same values resistors in this Wheatstone bridge. In case you have a 350 ohm, you have to use all 350 to balance it. And in one node, you are going to provide 5 volt, and that 5 volt DC is going to be provided from the DC power supplier. You know, in the right hand side you have a 5 volt, right? So that is being used. It's going to be connected like this to provide 5 volt. And by the way, this negative node should be grounded, and your amplifier that you're going to connect, it should be grounded as well, okay? And you are going to use this as your ground, just like you did for other op-amp circuits. And from the DC power supplier, the input nodes from the left-hand side are going to be used for powering the op-amp vs positive and negative, so that those should be connected to the amplifier. And so one side is connected to the excitation voltage, and the other side is being measured. Actually, that is being amplified, and you need to select at least 10 times amplification gain, and that is going to be measured using your multimeter, okay? It's not the oscilloscope this time. You're just using the multimeter to measure the voltage, okay? And the voltage at this point you're measuring after amplified is V out with the overbar. And so this strain gauge is being attached to a cantilever beam that you see here, and you are using a screw to secure it so that it becomes affixed in one side. And the other side, you have another screw, so you are rotating this, and this is kind of pushing the beam up and up and up like that, and you are measuring that using the dial gauge, okay? So from here you can measure the displacement in this direction. That is not the delta L. Delta L is, say you had a beam originally like this and it's being extended like that, right? So delta L is the amount that is being extended here, which is almost not really easy to measure, right? And what you are actually measuring is this thing. So you have to find delta L from this delta value we are measuring in this experiment. Okay, so delta L is not same as the delta. Okay, so what we are going to do is we are going to find the calibration curve for the strain gauge. So we are going to bend this thing by turning this screw, and then we are going to release that back to its original state. So you are increasing this delta, and then you are decreasing that delta again. And I would like you to increase the delta up to about 1 inch. So this is going to be 1 inch maximum. And then you may probably divide these into 10 steps. So for each step, you measure, the displacement and also the voltage that is amplified through the amplifier circuit. So in case you plot this, generally it may be like overlapping to each other, but in some cases, when you're going up and coming down, they have slightly different curve, and that is also something natural. It's something called hysteresis. And by the way, your strain gauge, you see, this guy is being shrinked. Like as you press, rotate this thing to bend this beam, this side of the beam is being contracted, right? So the resistor value is getting smaller and smaller. On the other hand, if you had your beam and strain gauge attached on the other side, that strain gauge is going to be extended. So depending on whether you have it here or there, you're going to have a value of this calibration curve going either down or going up. So don't worry too much if you have a curve that is going down like this. Okay, so again, you are going to use this guy and form a circuit, Wheatstone bridge, and also form an amplifier circuit using the op-amp to amplify and finally measure the signal. So we have like 3 tasks that you need to do, and then this is what you're going to do. Okay, so I'll see you guys in the lab.